Okay, so we'll start again. The first one was there's more than 12 students in the band room. Unfortunately, you can't see the words, but you can see the graph. So we had said that more than 12 students in the band room would be X. Let's try the pen. X is greater than 12. And so on our graph, we would circle at 12. It's going to be an open circle, and it's greater than, so we're going to fill in this way. All right, again, we know it's an open circle because we had to commit to memory that if we have a greater than symbol and only the greater than symbol, it's an open circle. And then you shade greater than, because this says that any value greater than 12 would make this statement true. So 13 would make it true because 13 is greater than 12. 1,000 would make it true because 1,000 is greater than 12. So we open circle, shade to the right. All right, our next example was the lunch table can seat at most 20 students, and we said that inequality was X less than or equal to 20, and we said that it was less than or equal to 20 because when we looked at our data chart, when we saw the words at most, it went with the less than or equal to symbol. So now we're going to have a circle at 20. Now everything we need to know about the circle and the direction of the shading comes from the symbol. Okay? Now this symbol says less than or equal to 20, which means that our value for X could be 20. We could have 20 students sitting at the lunch table, or we could have 10 students sitting at the lunch table. So we need to include that our answer could also be 20. So we shade in 20. All right, it says that the X is less than or equal to 20, which means we can have 10 students, 5 students, 1 student, even 0 students at the lunch table. So that means we need to fill in our number line to the left. All right, our next one was that Molly made less than $150 babysitting. We said that was represented X less than 150. So everything we need to know about the type of circle and which direction we shade comes from our inequality symbol. Our inequality symbol is a less than symbol, so that tells us that we should be shading to the left because our value 150, right? Any value less than 150 is going to make this statement true. So 50 is less than 150. So it's an open circle because it doesn't include the value of 150, but it is all values less than 150. The last example from the previous examples was the maximum the school can sell car magnets for is $10. And we said that inequality looked like this because at maximum was, or the maximum here was the key word. We looked on our chart and maximum fell under the grid for less than or equal to. So again, now we're looking at a less than or equal to, and our value on the number line is 10. Okay? The question is, what type of circle do we need, and in which direction are we going to shade our number line? So because this is X is less than or equal to 10, means that we could have 10. We could sell those magnets for $10. So we want to include the 10. So we shade in the circle. We could also sell the magnets for $9, $8, $7. So we're going to shade in our number line this way. If we went the other way, then we would say, then that would be saying, if we went this direction, that would be saying that our value for X could be greater than 10, and it can't. We can't sell the magnets for anything more than $10. So we have to represent numbers less than 10. Okay. All right, so let's look at some word problems that we need to turn into inequalities to then graph. Okay. This says the difference of a number and 5 is no more than 8. So remember, an inequality is two expressions that either one expression is greater than the other expression, or one expression is greater than and equal to the other expression. Okay? So we have two expressions we need to write. The first expression is the difference of a number and 5. The next expression is 8. And our key word to determine which inequality is no more than. Okay? So for the difference of a number and 5, I need to write this expression. The difference indicates that we will be subtracting. Okay? So I need the difference of a number and 5. Now because I've used the word difference, I am going to write my number, which we don't know, so I'm going to give it a variable x less 5, right? So we're taking 5 away from x. That's the difference. We're subtracting. All right? Is no more than. So I am going to pull out my chart, and I'm going to find no more than. The no more than is in the less than or equal to column. So less than or equal to. And then my final expression was just 8. Okay? Now I don't have a value set yet for my solution. I need to find what values could be plugged in for x to make this side of the expression less than 8. And there's more than one solution to this, which is why we graph it. So we represent all of the solutions. So I have a one-step inequality. I want to isolate my variable, and right now my variable is being subtracted or being decreased by 5. So what I want to do is, since I have minus 5, I use the inverse operation and I simply add 5 to both sides. Now what this does is it cancels out, leaving only the x on the left-hand side of the inequality symbol. I keep my inequality symbol, and then I say 8 plus 5. All right, which is 13. Okay, now I have something that I can graph. I have my variable is less than or equal to 13. So any value, if I was to look at my original inequality, any value less than or equal to 13 will make this statement true. So if I say, what if x was equal to 5, right? Because x can be any number less than or equal to 13, and 5 is less than 13. So if I said 5 minus 5, okay, and then I did this math, this is 0, and then I read it. 0 less than or equal to 8. Is this a true statement? Yes, it is true, because 0 is less than 8. All right, let's look at another example.